Hello and welcome to an exciting episode of Ruby for Web Developers. I'm your host and your professor, Dr. John Baugh. Today we're going to be talking about Ruby as a language, specifically about some of the fundamentals, including data types. So the way this is going to go is I'm just going to do some examples and show you how to get things working. Once you have Ruby installed, and if you are not sure how to do that, I would say make sure to refer to the documentation that I provide on how to install it. But once you get it installed, and you also should have Git Bash or some form of Bash installed, I would prefer that myself, but if you're one of my students and you turn in a Ruby file or anything like that, it really won't matter what you used. You may not even be using Visual Studio Code. You might be using some other IDE for Ruby, and that's okay too. So for everyone watching, one of the things you want to do is say Ruby -- version, and as long as it doesn't return something like, I don't know what that command is or what does Ruby mean, then you're probably good to go. So as of this video, 3.4.5 is the most recent. In the future, that will probably increase, very likely. I think there's some slightly higher, less stable versions available, but I got this one. So let's do a couple things. The first thing I'm going to do is introduce you briefly to IRB. So if I do IRB, that is the interactive Ruby. And you can always exit it just with exit, and that'll get out of it. So interactive Ruby allows you to interact with it much like you would if you are coming from Python or a language, an interpreted language. You can execute them line by line. Okay, so for example, I might say put s 7 divided by 2. Okay, and it will do integer division. So that's why we get a 3 and not a 3.5. Right? So other things you could do, put s, so it means put string, so you're sending the string to the console essentially. So now if I did something like put s 7.0 divided by 2, that will do floating point arithmetic, meaning it will take into consideration that there are decimal points. So 7 divided by 2, each of those is an integer. So when you do division, it's doing integer division, which means it will remove or truncate the decimal place. Okay, which would be the 0.5 just disappears. Another thing you could do is say put s 7.f div 2. Okay, and then that will also do floating point division. You're basically calling this fdiv method on this. So that's another way to do it. Now, we're not going to spend as much time in interactive Ruby, so I'm going to exit. And we're going to actually create a file. So first I have to find a folder to put it in. So I'm going to go to File, Open Folder. You could create a full workspace in Visual Studio Code, but I don't tend to do that. I tend to usually just work off of bare file system. I have a folder called workdir for working directory as my top level folder, but then for each project, for example, Lecture 1, Ruby, DT fundamentals or something like that, you could make it shorter, longer, whatever. It probably makes more sense. Oops, I deleted it accidentally, but that's okay. Lec1, Ruby data type fundamentals. There we go. So I'm going to select that folder, and that is our working folder now. Okay, for this project, that is our projects folder. I'm going to go to Terminal, New Terminal, and because I have this set to use Bash by default instead of the PowerShell, which is the default on Windows. If you're not on Windows, you're not going to have to deal with PowerShell. You'll have other options. But if you had installed Git Bash, you will get the full system that you need in order to issue commands in more of a Unix, Linux style, and that's the style we're going to use in this course. So the terminal is there. Now I want to do a couple things in here to get this project going. So right now it's just basically a folder. If I want to have a little bit of isolation for an environment, then you're going to use Bundler through Ruby, which creates what's called a gem file. Instead of, if you're coming from a Python environment, you're familiar with venv possibly. That creates an isolated environment. So those tools will isolate the environment for the programming language dependencies and the interpreters and their specific versions without affecting global settings, okay, system-wide settings. So the first thing we're going to do is we'll say gem install bundler, and that will install the bundler gem, which is the dependency management tool for Ruby applications. The bundler will help to resolve all the necessary gems, and when I keep saying gems, we're basically meaning Ruby libraries. Okay, these are collections of code that they've written for us and that we can use. Okay, they could be made by the Ruby individuals themselves that maintain Ruby. There's all kinds of stuff that they could be. They could be made by independent developers or companies or what have you. Okay, so bundler helps us to resolve what's called dependency hell. That means that different gems might conflict with different, different scenarios and things like that. So it helps us, different environments. So it helps us to keep things separated and organized. So once we have this, we've installed the bundler. I'm going to say bundle init. And you'll notice that creates this gem file up here. Okay, so that's the gem file. Now, by default, this is commented out, okay, but we could, for example, install the Rails gem if we needed Rails for Ruby on Rails for the web development. But for right now, it's telling you where it's getting the gems by default. We could include other gems, though. We don't really need Rails right now. We don't really need most of these, but I'll just type some of them. So our spec, if we wanted to, we would put that as a string, though. Our spec, that's for like testing. You might do Rubocop. It's like Robocop. See, really funny. This would be for linting and styles. That helps with the stylistic stuff and can lead to better code in general. You might say you want a debugger. So maybe development. That's the debugger. It's optional but handy. So in order to use this gem file, so the gem file is where you list your dependencies, okay? And once we have those dependencies, I might decide that I want to actually install them, have them actually installed in here. So let's do this. We'll say first command is bundle config set path, and then in single quotes usually vendor/bundle, and I'll hit enter on that. You'll notice that will create a subfolder called bundle, okay? And it'll take the current folder and go in there. And if I say bundle install, that's going to actually create the vendor folder, okay, that we wanted. And inside there, it installs all of the different gems and different other documents that are related to this that are needed, configuration files and things like that. So if you don't put the build config set path, it'll often try to install things globally, and we may not need that. So we're trying to keep this as an isolated environment. So we're giving it a couple minutes, and it should have everything going quite well in just a moment, and we should be able to just use it. All right, so I paused it for just a few seconds. It took under an extra minute, but I didn't want you having to wait around for it. But it installs everything you listed in the gem file, and then anything those things depend on. So it's grabbed all that stuff and then basically installed them underneath this vendor folder. This vendor folder has all these gems in it. You'll see this is quite a bit of stuff. So it's very similar if you've worked with some other web development where you've dealt with NPM and node modules and things like that. If you haven't, have no idea what that means, totally fine. But if you have dealt with those things, then it's a package management system basically is what it's doing. So we're keeping it nice and organized. It's just to this project. It's not globally available. So we don't put a bunch of stuff in projects that we don't need. But for right now, I just did that mostly to demonstrate. So some of the stuff we were doing with IRB, I'm going to do at the top level here. I'm going to create a new file, numbersdemo.rb. And inside here, we're going to do a bunch of these lines of code. So we're going to do put s, so 7 divided by 2, fdiv, so that's the floating point division, put s. Now, this is a really interesting one. If I say 2 dot plus 3, that is the same as the operator. So if I say put s 2 plus 3, that's actually a shortcut for the one above it. The one above it is actually what Ruby's going to call. So it's calling this method, essentially, that its name, the method's name is just the plus symbol. So it's basically, it's kind of like how operator overloading works if you've taken a C++ course or C#, or you've worked with operator overloading. It's kind of the same idea as that this is what we would call syntactic sugar. That's the most natural way we write it. It's what we call idiomatic Ruby, is to write it just with the plus sign. Put s for 2.class, and this might seem a little strange coming from certain languages because we're taking like all these literals like 42 and 2 and 7, and we're calling methods on them. But essentially everything in Ruby is treated like an object, okay? Every variable, every constant, everything is going to essentially be an object in memory. And it's going to be, all the variables and everything actually hold references, so they hold addresses, and all the actual data lives on an area of memory called the heap. Again, if you're not familiar with these terms, don't worry too much about it. We'll get there, just pay attention to the actual code and maybe follow along as much as you can. Now, this is going to be a 3 divided by 4 rational division, so that's what the R means. And then put s 2 plus 3i, that's for complex numbers. Okay, I'm going to save that file, and then down in the terminal window down here, okay, so I think I'll make all of our lives easier, or at least try to. We're going to go to File. I don't like the size of the font down there. It's a little bit small. So File, Preferences, Settings, and then you can search for Terminal Font Size, and it will bring it up. Terminal Integrated Font Size. It's currently 14. Let's see what 18 looks like. That's better. That's a little bit better, isn't it? A little easier to read, I think. So we'll keep that. We'll close that. There we go. So now I'm going to actually try to run this code. 1 second, sorry. Got my lecture notes over there. Okay. So we're going to run this code with just Ruby, and then I'm going to say numbers underscore demo.rb. Now, right there, I just typed, just so you know, I typed Ruby out because that's the command. And then I typed NUM and then hit tab. And since nothing else starts with those 3 letters in this directory, so we're in the directory of this project essentially that we created. Since nothing else starts with NUM, it will auto-complete the rest of it. Okay, so the Ruby numbers demo.rb, and there we go. We get the printout for each of these because that's what we told it to do. So just to go over what we've done here, we have in Ruby, everything is an object, even 5, the number 5, the literal, is not a primitive like it would be in, say, Java or C++. It's an instance of the integer class, okay? So that's why you can call methods on it, like 5.class or 5.2f and things like that. The class might look like a property. Also, if you're coming from C# or some other languages, you might look at this and say, well, that looks like a variable or a property that just happens to be public inside the class. But it actually isn't. Ruby actually allows you to treat parentheses as optional, right? So that would be kind of the default behavior right there. Okay, or the default, not default, but the typical way that we would see it. It is idiomatic for people that are, typing it from another language. This looks more natural because it's a method. But Ruby allows you to not have to do that. Okay, so you could just do this without the parentheses. So it's a method call, just doesn't happen to have any parentheses. In Ruby, parentheses on method calls are usually optional, especially with no arguments. If you have arguments and it's not ambiguous, then leaving the parentheses off is kind of a stylistic choice that a lot of people will choose to do. So like up here, I can change that to a 2. That should work. It does. Yep. So you don't even need the parentheses for this one or this one. So, but I prefer using parentheses in general because other languages do it, and I think it's a little more descriptive and it avoids ambiguity. Okay, but you'll notice we're getting the same situation down here every time. So, and as I alluded to and mentioned, the operators themselves are actually methods. So when I say 2 plus 3, this is just syntactic sugar for the one above it, meaning it's syntactic sugar means it's not necessary really, but it's an easier way to write something else that's more complicated. But the original way that Ruby interprets this line is it will actually call the plus method. Okay, integer division, unlike something like Python 3, Ruby will truncate integer division if both operands are integers. So 7 divided by 3 is actually 3, not 3.5. So you would need a float or to use the fdiv, like we did here, in order to get exact real number division, floating point division. Ruby also has built-in literal syntax for things like rational numbers. So that means numbers expressed as a ratio of two integers, rational numbers, and complex numbers like 2.3i, which is unusual for a mainstream scripting language. All right, next up, let's talk about strings. Okay, we'll write some code and then we'll talk more about it. So I'm going to create another file. This file is going to be called strings_demo.rb. And inside here, I'm going to create some variables and work around with this. I'll say name equals and then double quotes Alice. So I'll say put s. I'm going to try single quotes and then see what that does. Put s, and then we're going to do double quotes with a \n inside of that. See if that gets different behavior. Then we'll say hi, and then notice here some syntax here. We're going to put a $, and then inside curly braces, I'm going to put the name of the variable that I created earlier. Okay, and then put s, I'm going to say 2 plus 2 equals, and then again, $, and a set of curly braces. I'm going to put 2 plus 2 inside there, so we'll see what that does. Then we're going to do something down here, word equals Tim, and then what if I just want to grab, let's capitalize that. If I want to just change the name from Tim to Jim. Okay, so word at 0 equals J. So what does that even do? We'll see in just a moment. Okay, so let's do Ruby and say strings_demo.rb. We'll hit enter. And you'll notice what it's doing. When I do single quotes, it does not interpret things like \n. It doesn't interpret escape sequences like this, okay? So in order to do this or grab variables and things like that, you have to use the double quotes. Single quotes are just a very, very straightforward, quick and dirty way to print out a string that doesn't try to, it's more efficient really at the end of the day. So if you need super efficiency for something that's on a very small amount of memory environment, a low memory environment or low processing environment, it may make sense to do things like that, right? Okay. With double quotes, you'll notice you don't see it print out \n, but it does just go to the next line, okay? Put s, okay, put s will, it obviously puts the string. Now what happens when we put hi and then put this gobbledygook here? What does this even mean? So hi is part of the string literal, and so is this exclamation point over on this side. But what does the £sign and then a set of curly braces, anything inside of it will be interpreted as a variable or expression of some sort. Okay, just some sort of expression including variables, or as we did down here, something slightly different. We actually performed mathematics. Okay, so this is called string interpolation, and this is the interpolation syntax. Okay, so down here we have word equals Tim, so that was me creating a variable holding the string word Tim, and then we put word at 0 equals J. Okay, so what am I doing? When I say word at 0, what's going on here is that it's treating this like an array. Now, we haven't looked at arrays just yet, but you can think of this as having a bunch of containers. Okay, so let's say we have position 1, position 2, or I'm sorry, the first position, second position, and third position. These are actually labeled as 0, 1, and 2. Okay, so the T, character T is in that one, the character I is in that one, and the character M is in that one. Okay, so you have T, I, and M. T is at 0, I is at 1, M is at 2. Now what happens if you say word at 0 equals J? In Ruby, the strings are mutable in this way. So that means that we can actually modify individual characters. It changes using this index 0 or this subscript 0. It can change that T to a J, and then the name will be Jim. So what should it print out? Jim. It doesn't print out Tim, it prints out Jim. Excellent. So again, these are objects. Strings are objects. Hello is an instance of a string. Okay, so if I put hi or hello or Alice, those are all instances of a string. You can actually say something like this. So if I want to do at the very bottom, let's say I want to do put s and then say hello as a string. Okay, if I run it right now, it'll print out, oh, it didn't, where did it, oh, it didn't save it. That's what happened. I didn't save the file. You have to save it. Okay, now it says hello, but you can actually call methods on it because it's an object. So I can say dot upcase, and I would put parentheses on it like that and save it. Okay, and now you'll see that it's all uppercase because that is a string method called upcase for uppercase. You could also leave the parentheses off and it will still call a method even though it looks like a variable, right? Still doing it. Okay, single versus double quotes. Again, when you put the single quotes, it will literally print out the \n. It won't try to interpret it as an escape sequence. And if you do double quotes, it'll interpret it as a new line. Okay. What about hello name? Again, that's the string interpolation, and that's the interpolation syntax. You can put any expression, not just a variable, but I could put a variable here. I could put an expression 2 + 2, like I did down here, and it gives me a 4, right? Strings are mutable in Ruby, unlike Python or Java. They are mutable in Ruby like they are in C++. So you can modify individual positions. That's how we were able to change Tim into Jim. Okay. Java does have something like called string builder where you could modify individual components. But for our purposes here, we just assume and know that strings are mutable or they can be changed. Okay. So what does the put s mean? Okay, if it wasn't clear enough or you didn't catch what I said it stood for, it stands for put string. It automatically converts its argument to a string with 2_s. Okay, so if you do 2_s, that is actually a method for changing something to a string. And it automatically adds a new line. If you don't want the new line, you can use print instead. Okay, so we've got our example for that. Now, the next one up is we're going to create another file. This one is going to be called arrays _demo.rb. Okay, there's our arrays demo. And for this one, we're going to put nums equals, and then 246, and then nums, and then this kind of squirrely syntax here that looks a little bit unusual. And then we're going to do put s num.inspect. Okay, and then down here, put s nums, sorry, it should be nums, not num. Nums.first, put s nums, and then at -1 to see what that does. Nums.each, and then in curly braces, I'm going to put this kind of weird syntax, put s and then number like this, okay? That R should not be capitalized. We'll fix that. Nothing special about it, though. There is something special, so you have to do that. And then down here, we'll use, this is the multi-line block form. I can do it this way. So nums.each do n, and then put s n times n, and then at the end here, just put n. Okay. Now, the spacing here, Again, if you're coming from Python, you have requirements, like it has to be 4 spaces and things like that. Ruby does not require spaces because it actually it delimits the beginning and end, so it puts an end here. A lot of languages use curly braces, like Java and C++ and C#. Python depends entirely on white space. Ruby does not. You could put a lot of this on like the same line, as long as you have things like end. Okay, let's run this and see what happens. Ruby arrays demo. Okay. Oh, it looks like there's an error here. Oh, that should be puts, not pus. Sorry. There we go. That was an error. It looks like I did it again. Okay, what do we got here? Was it put s n times n? Oh, I put nums. That was weird. All right, we'll just do n times n. I'm just not doing well today. Okay, so there we go. We got everything fixed, but these are common errors you'll come across, and you just got to read it carefully. It'll say, the block, it'll say, well, that looks like an array, so it's not sure what to do with. What do you mean by multiply an integer by an array? Okay, how do I... This is saying I can't convert an array to an integer. That's what it means. Array can't be coerced into an integer. So I immediately saw what line it's on. So it says line 12, and I looked and saw that I put n times nums instead of n times n. So that was a mistake. All right, but now it's working. It's printing out everything it should. It prints out the full array like we told it to. And when we do, nums.inspect does that. Now, why does it have an 8 at the end? When did I put an 8 in there? This is 2, 4, and 6. Well, this is what happened with these less than symbol right here. That is not doing what you think it's doing if you're coming from C++, because in C++ we use this symbol and it's called the stream insertion operator, and it helps you use things like cout to print stuff to the console. Just like we're using puts, C++ actually uses that to help it print, right? But for here, this is different in Ruby. The 2 less than signs is called the shovel operator. And that's Ruby's what we call idiomatic way to append things. It's equivalent to calling dot push, but it's less, it looks more concise. Okay, so for example, if I commented that out and then I reran this, it'll just do 2, 4, and 6, right? So what if I do nums dot push 8? It should work. We get the 8, right? And also you could do the syntax without the parentheses, push 8, like that, and then I rerun it, make sure it's saved. And I see that the 8's there again. But a lot of people that use Ruby use the shovel operator because it's easy. Okay, it's simple. This is basically saying push it to the end or add it to the end. That's what push means when we're talking about arrays. Okay. Arrays are ordered collections, similar to Python lists or arrays in other languages. They're zeroed indexed, meaning the element right here, that 2, there's a 4, there's a 6, there's obviously 3 elements, but 2 lives at index 0, 4 lives at index 1, and 6 lives at index 2. When we push the 8 onto it, that will live at index 3. Now, it's a dynamic array because it's allowing you to add stuff after the end of however many elements there were previously. So it is dynamic. It allows you to add things. So you could think of it as shoveling onto the end. So the C++ analogy would be push back on a vector, or in JavaScript, the push method, if you've coming from JavaScript. Now, I will make mention of a lot of other programming languages. You may not know any of them, and that's totally fine. You don't need them in order to understand Ruby, but I'm trying to show links where links occur as needed, or as I think it would be useful. Now, how would you remove an element? I didn't really do that here, but you could actually, you might think that there's a, this symbol right here, but by default, there's not really, people don't use that symbol for that. If I wanted to remove an element, I could use pop or shift or delete. So you could actually, or delete at rather. So if I want to remove the element from the end, again, after I've printed them, okay, so let's see here. So this, inspect prints the array. So what happens if I say nums.pop, and then I say put s nums.inspect again, okay? So what happens? Okay, you'll notice that the 8's missing. Now, instead of pop, which we again could have done without a parentheses, what happens if I say shift? Okay, let's see what that does. You'll notice in this one, the 8 stays. What got removed? The front. Okay, so shift removes the front, pop removes the back, and then if I want to remove a specific element or index, I say underscore delete at, and then pass it the index. So let's say 0, 1. I want to remove the 4. It's at index 1, right? So even after we add this 8 here, we would have 2, 4, 6, 8. When we remove the 4, it would be 2, 6, 8, right? So let's see if that works the way we want it, and it does. 2, 6, 8. Okay, but we're getting ahead of ourselves on that. I'm just going to comment this out. So it just goes back to what we had with the 2, 4, 6, 8, and then printed out the individual numbers. How did it do that, or why did it do that? It used iteration with what's called each. So this is it's kind of a functional syntax rather than us explicitly saying there's a loop here. We're saying nums.each, and then in curly braces, this might look almost like magic or like foreign language, even if you know 2 or 3 other languages. But what this is doing is the stuff in between the vertical bars, which are above the enter key on a standard US keyboard. The 2 vertical bars, you put, say, n in here. This is a temporary variable. You could name it whatever you need it to. You could call it my num. And I could change this right here to my num, and that should work just fine. Okay, which it does. It does exactly the same thing. So the stuff that goes in between the 2 vertical bars, this declares what's called a block parameter. And it's kind of like function parameters. It's the data that goes inside of this, and it's used inside the block of code, referring to whatever current element is. So what happens here, follow me, nums contains 2, 4, 6, and 8. Okay, it's an array. We call the each method on it because arrays are objects, so that means they have methods. We call the each method on it, and then when we do this and say put s number, we just use our little string interpolation syntax, my num. This has to match that for using it. So this parameter right here, as we go through here, it represents each element as we go through. Okay, so that's basically looping through each one. So it'll start at the first element, the 2, okay, at index 0, and the my num will take on the value 2, and then it'll say put s number colon, and then it'll print out the 2, and then it'll actually automatically go to the next element because we told it I want to do this stuff for each of the elements in this array. So it'll then do the 4, and it'll say number colon 4, and then the 6, number colon 6, and then number colon 8, right? And that's why we get that down here. Now, you could also use a different technique, different syntax. You could use multi-line block form. In this case, we don't have the curly braces surrounding it, don't need them. We just have a do and an end. So if you're familiar with kind of like a do while loop, this again is a block parameter, okay, and it's good inside this block. And it's going to say for each of the elements in the array, every time we're on a single element, name that element n. Okay, that's its temporary name. It's its alias. So the first element, it'll print out n times n, so it'll say 2 times 2, so that should print out a 4, which it does. And then the second element is a 4, so it'll say I'm in the array, I'm now at index 1, so I've got the 4, and it'll say that's the parameter, n equals 4 now. Put us 4 times 4, and that gives us 16. And then so on and so on. We get 6 times 6 is 36, 8 times 8 is 64, and etc., etc. Okay? All right, now, hopefully that was useful for you. Now let's go on to the next topic, another fundamental idea within Ruby. This is going to be hashes underscore demo.rb. Okay. Okay, for this one, you might be able to pause the video and guess what's actually going on, but I'll write it out and then we'll talk about it. So say that, and then Bob is, say, 82, and then put s grades at Anna. Put s, okay, and then we'll do some idiomatic symbol keys. Okay, say person equals, name is Sam, age is 21, and then put S person, and then we'll say colon name. Okay, so we're going by the key in that one. These we're actually giving names. Now, if we print this, let's say Ruby hashes demo, we get 90 and we get Sam. So what's going on here is that we're using hashes. And a hash is Ruby's version of, say, a dictionary, like in Python, or a map, and they have key value pairs. Okay, so kind of like an array. In fact, some languages in C++, a lot of times you'll hear them referred to as associative arrays because they are array-like in their structure, but instead of using standard indices 0, 1, 2, 3, 4, 5, integer indices, and the actual data can be anything, the keys here are more varied. For example, you could use string keys like we have here, or you could use symbol keys like we have here. Okay, these are more considered more idiomatic, meaning they're more natural to type this way. But some languages, this actually looks more natural up here. But this is how you would do it. So if I have grades and I want to assign Anna, okay, as if Anna were an index, Anna's the key, and the value that corresponds to Anna, I have like an arrow, so it's like equal sign and then greater than sign, looks like an arrow. You shouldn't put spaces in between there. So Anna 90, and then Bob is 82. Okay, so put S grades at Anna, so using it kind of like an index, it will print out the corresponding value for that key, Anna. And that happens to be a 90, and that's why we get 90 down here. So what about the symbol keys? Well, the symbol keys, I put name is Sam and age is 21. And if I want to, this represents a single person, not multiple individuals. In this case, if I want to represent that single person, I can actually grab data about that single person using put S person, and then you put the colon in front of it, and then the name of the key. So colon name or colon age, right? So if I put age, it will print out 21, okay, which is what we expect. Alrighty, name. Now, for Python, it would be dictionary. So the hashes are dictionaries. For Java, you would have something like a hash map, but Ruby is dynamically typed, so that is a difference there. C++, it's kind of like associative array or unordered map, right? Okay. Next up, now, so this is using symbols, so we're kind of ahead of the game here. These are symbols like name, but we're going to actually talk more deeply about symbols right now. So let's do symbols demo.rb. Okay, now a symbol is kind of like a string, literal, but it's immutable, which means you can't change it. And it's what we call interned, which means only one copy of it exists in memory. Okay, so let's write some code here. So I'll say roll equals, and I'm going to say student. That's my symbol representing the student. Put S roll.class. We're going to try to see what is roll. If I said colon student, what kind of value is that? Person is equal to, name is Anna, and then roll is, colon student. So that's not a syntax error. The first colon is to tell it this is the property or the key roll, and then its value is colon student, meaning it's a symbol. Okay, now put S person. We're going to take that person object and grab its role. So it should print out something about student, right? And then put S, I'm going to say colon name, okay, dot object ID, okay. If the object ID equal to name dot object ID, let's see if those are true. We're just going to print it out. This is a relational operator saying, is this one equal to that one, just to see what happens. Okay, it's going to use the same object. Okay, so that's going to prove to us that it's the same object, meaning that they're going to hold the same data. Okay, Ruby symbols demo. So it is giving us a true for that. It's giving us symbol as the type when we say put s role.class. Okay. And student, when I print out the role, it just prints out student. It doesn't put the colon in front, but that's its role. It just prints out student. It converts it to a string essentially when it prints it to the console. So symbol again is like a string literal sort of, but it's immutable, meaning you can't change it, and it's interned, meaning that only one copy exists in memory. So it's like a singleton. Okay. So the syntax is that they start with a colon, such as colon student or colon name, things like that. And they common use would be things like hash keys, enums, identifiers. They behave like lightweight labels, not text data that you would manipulate. For language tie-ins, I would say there aren't really any good analogies in Python or C++ or Java. I would say in Python, maybe the closest would be like enum members, or using string keys but with less overhead. C++ and Java, you could think of symbols as maybe like interned strings or enum labels, and then JavaScript actually has symbols which have some similarities to these. Not exactly the same, but similar. So symbols are like named constants that Ruby stores efficiently under the hood. They're great for labels, but not for user-facing text, so you wouldn't generally use them for that. Okay, next up, we are going to look at, it seems like we're going backwards, but this is a good progression. We're going to say variables demo.rb. Okay, and let me see here. We're going to create a variable Tim, b equals a, see what that does. A at 0 equals j, so I'm changing that character. If I say put s a, and then put sb to see what both of those print, pi 3.14159, put s pi, and then what happens if I try this? Pi equals 3.14. Can I change it? Let's see what it does. So if I run it, actually put s, we're going to say variables demo. Okay, and you'll notice it'll say variables warning, already initialized constant pi. Previous definition of pi was here. So it's not liking that. Okay, now why doesn't it like that? It's just a variable name, right? Well, Ruby actually recognizes anything that's uppercase, starts with an uppercase. Usually we do all uppercase, but it really goes by the first character in the variable name. So if I create a variable, quote unquote, with an uppercase letter in its first position, like P, okay, we could put a lowercase I, but that wouldn't be very idiomatic. It will know automatically that that's supposed to be a constant. Okay, local variables we typically use snake case. So I would say something like you could use camel case, but you could say something like sales tax or something like that. That would be a good name. But with constants, as long as they start with a capital, that means it's a constant. Okay, so just remember that. All variables in Ruby are references to types. Okay, so that's what we mentioned before. So I'm going to comment that change of pi out and just get our little printouts here. So what does it mean that we have an object that we're creating in memory on the heap, Tim? We have a pointing to that object, and then when I say b equals a, it does not make a full copy of the object. What it does is it copies the memory address. Okay, so that means when I say a at 0 equals j, that changes Tim to Jim in the object. And then you would expect when I do put S on A, it prints out Jim, but why put S on B? Why does that print out Jim? Shouldn't it print out Tim? The answer is no, because they're pointing to the same exact object. They hold the same memory address. Again, B equals A copies the address, not the whole object. Okay, so reassignment just points the variable name to a new object. Okay, so again, naming conventions, local variables use snake case, which means underscore case, like sales underscore tax, or you would say Michigan sales tax, something like that. If that was supposed to be a constant, as long as you start it with a capital, you could do it anything you want, like that. That's kind of dumb, but you could do that. That's a constant because the M is capitalized. Typically, we would do something like MI sales tax, right? And then we'd say 0.06 or something like that, right? So there are different scopes by prefixes. I'll put that here. We haven't really gotten to object-oriented stuff, so this is a little bit of a chicken and the egg issue. But let's say, okay, so a local variable, if you do local variable, that is, you can just say local var. You can actually prefix the variable with local, and it will make it a local variable, or any kind of snake case, right? Some people choose to actually use that keyword, or that word. It's not really a keyword. But typically you would just, as long as you put it in snake case, it's a local variable. Now, other things would be things like the @ symbol. Okay, so single, this is going to be an instance variable. Instance variable, so it's at anything underscore, right? If you do a double, this is going to be a class variable, so that's basically it's a class variable, okay, but it's like a static variable in C++, Java, C#. Okay, what else? If you want something to be explicitly global, you can say global var. That is a global variable, meaning it's available anywhere in the file, not just inside of a function, which we haven't really gotten to, or a class. So everything's pretty much fairly straightforward, I think, as far as the descriptions. Now, another thing, kind of our last major topic that we need to go over, again, seems like we're going a little bit backwards, but we're going to do input output demo.rb. I'm going to do print instead of put s. Enter your name. Notice I did leave a space. There's a reason for that. Okay. And then name equals gets.chomp. Okay. Now this, again, is a method, so you can put chomp like that or just without parentheses. Now I'm going to do put s, hello, and use string interpolation. Okay. And then I'm going to do print, enter a number, n equals gets.to_i. Again, it's a method, so you can do that, but it doesn't take any parentheses, so you could leave it without. Put s twice, that is, okay, we're going to do n times 2. There we go. Let's see what happens. Ruby input output demo.rb, enter your name. So it's actually prompting me. So I'm going to put John. Hello, John. Enter a number. We'll say 42, and it'll say twice that is 84. So put s is, again, put string. This will it'll print, convert to a string, and then add a new line in. Print does the same thing, except no new line. Okay, so that's why it waited for me on the same line for me to type something. The P is debug print, okay, just to make you aware. And get s, so that will read a line from standard input as a string with a new line character being the delimiter. Chomp is pretty much what it sounds like. It's taking a bite. It's removing any trailing new line, so that's why we don't keep the new line as part of the name, because when I type John and hit enter, that new line from me hitting enter is actually part of the string. So when I say chomp, it's removing the trailing new line character. So language tie-ins, I would say that for Python, it's similar to using print and input. With C++, it's similar to using cout with the stream insertion operator and cin with the stream extraction operator. And for Java, of course, we would have something like system.out.println to do output, and then using a scanner to get input. Okay. All right. So for this particular video, that's what I have for you. I hope that was useful and went over some of at least the fundamental ideas with Ruby. We didn't do anything with web. It's going to be a couple lectures before we do anything related to web. We still have to get through things like control statements and more on functions and things like that. But this is fundamental Ruby. We need to know the language even before we dive into, specifically before we dive into the actual using it to develop any kind of web service or any other kind of REST API or anything like that. All right, so that's what I've got for you. If you have any questions, please let me know. Bye-bye.